In problem 15, we're going to arrange books again. So this time we've got 10 books, and we're going to put them on a shelf, but this time a particular pair of books has to be next to each other. Let's start it like this. Here's our 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, there's our 10 positions. Let's make that one a little bit better. So here's our 10 positions, and what we want to do is take a particular pair of books and write those and stack those together. So where could those two books go? They could go in the first two positions, right? There's one spot they could go. They could go in these two positions. There's another two positions. They could go in this position. There's a third choice. They could go here, fourth. They could go here. There's 5 different positions. They could go here. There's 6. They could go here. That's 7 different ways. They could go here. That's 8. And they could go in the last two positions. There's 9, which makes sense. We can't get 10 because we can't start a book over here. There's no place for its other part to go. So as far as making decisions, the first decision is in what 2 slots should we put the pair of books? There's 9 ways to make that decision. Then, once we make that decision, like suppose we decide on this position right here, in these 2 slots, well, we could put either the first 2 books in that position and then 1 in this one, right? There's 2 ways we could arrange these, right? 2 and then 1. So what we're going to get here is a 2, really a 2 factorial, which is just 2. But then we've positioned 2 books. There's 8 other ones. So those 8 others, those could go in any order. So like, for example, if we put the 2 books here, then there's 8 other positions. And we could put any one of those 8 here, any one of 7, then 6. So do you see this? This is going to be an 8 factorial. So that's the number of ways that we can arrange those books. And when I multiplied this out, I got 725, 760. Number 16, we've got 8 women and 6 men, and from them we're going to get a committee consisting of 3 men and 3 women. But what we want to know is how many ways can we do that if 1 man and 1 woman just refuse to serve together? I'm going to start this problem like this, just so I can kind of summarize what's going on. We've got 8 women, 6 men, and what we want to do here is to select 3 men. So what we want to do is choose 3 men and 3 women to serve on this committee. But now what we need to do is count the number of ways we can do this if one particular man and one particular woman refuse to serve together. So here's one way that this could happen. Like, what if you take, say the man does not serve and the woman does not serve. In other words, neither one of them are on the committee. So we could count this. What's the number of ways that the man does not serve and the woman does not serve? That could happen, right? Keep them both off the committee. Or maybe exactly one of them's on the committee. So maybe the man serves and the woman does not. Or maybe the man does not serve and the woman does. So let's count these. Now, the first thing we're going to have here is the very top one. That's going to be this one right here. We don't want the man or the woman. So maybe what we could do is this. For maybe the man and the woman, now how many men are there all together? There's 6 men, but we're going to toss one of them out, right? We're not the fellow who's being a little obstinate here, we're going to toss him out. So there's going to be now 5 men from which we can choose, and we want 3 of them. And then for the women, there's 8 altogether, but we're going to toss out this one particular woman who refuses to serve, so that leaves us only 7. So from 7 women, we're going to choose 3. Or, now the or is going to be a plus here, so we're going to have a plus, all right, and then we have, let's get the man, the woman. Now, that's going to be this case here that I drew. The man's going to serve, but the woman is not. So the man serving, now there's 6 men altogether, and we want 3 of them. So the man can serve, so we're going to, from all those 6, we can still choose. So from 6, choose 3, but we don't want this obstinate woman to serve, so from the 8, we'll toss her out. That'll give us 7. We're going to choose 3. Or, let's go this way, a plus, got the man and the woman, and let's toss that obstinate man out. So from the 6 men, toss out the fellow who refuses to serve. That leaves us 5, and we want any 3 of the remaining ones. So out of the 5 remaining men, choose 3, and then the women, well, all the women can serve, so there's going to be 8, and we're going to choose 3. So there we go. That is our answer right there. And I actually computed that out, and from that one, I got 910. Well, no, I didn't. I really got, let me read that properly off my calculator. When I did that on my calculator, I got 1610. I got 1610.